Okay, before we talk about the example one actually, which was graphing the cosine function, I want to come back and understand the basic cosine function, y equals cosine of x. It looks a lot like sine of x. It's a wave. But remember, sine of 0 is 0, cosine of 0 is 1. So really, the cosine of x is the sine function shifted by pi over 2 units. But don't worry about that. Just understand what the cosine looks like. Cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is minus 1. 3 pi over 2 is 0. And cosine of 2 pi over 2 pi is 1. So it looks like this wave, and then it repeats. Keeps repeating. Infinitely in both directions. So the domain is minus infinity to infinity. The range again is minus 1 to 1, which means it has an amplitude of 1. Height is the highest it gets is 1. And its period is also 2 pi, just like the sine function. Okay, so likewise, when I had a sine of bx minus c, we can also think of what y is when it's a cosine of bx minus c. It's all the same stuff. Amplitude is the absolute value of a here, the absolute value of this coefficient. The period is 2 pi over b, the same as it was when we were looking at sine. And the phase shift is c over b, this c. Remember, it has to be minus c. So again, if c over b is greater than 0, we shift left. So I should push that over for you. If c over b is greater than 0, we shift left. If c over b is less than 0, we shift right. Okay? Because if it's a positive number, I'm subtracting a positive number, then I'm shifting to the left. Okay? So let's go back and look at example 1. All right, so example 1 was this guy. Determine the amplitude, period, and phase shift of y equals minus 2 cosine of pi x minus 3. So I'm not doing anything here to graph it. I just want to make sure you understand to do the amplitude, period, and phase shift again. So the amplitude is the absolute value of minus 2, which is 2. So this minus 2 would mean it reflected about the x-axis. But the height, the highest it will get above the x-axis is still 2. The period is 2 pi over b. b here is pi, so the period is 2. And the phase shift is c over b, so c is 3, because remember it's minus c, so c is 3 over pi. All right, let's go down and look at example 3. So in this one, I'm actually going to introduce vertical shifting to you as well. So we're going to look at graph of y equals minus 2 cosine of x over 4 minus 2. So whenever I'm adding or subtracting a constant to a function, I'm shifting it vertically. That's all I'm doing. So all I'm doing is adding or subtracting, I'm subtracting 2, which means I'm going to shift it down the y-axis 2 units. So all I do is I come down first and I draw this little dotted line across and I pretend that's my x-axis as I'm graphing it. Okay, this dotted line across at y equals minus 2. That's what this minus 2 here on the end does. It shifts it down 2 units. Then everything else I work the same. The amplitude is the absolute value of the a here. A is minus 2, so the amplitude is 2. That means the highest it would get above this new line, dotted line I'm thinking of as kind of the x-axis now, we get 2 units above that. So you can see the highest it gets is 2 above that, which is right up here at the x-axis. The period is 2 pi over b. So the b here is the coefficient of x, which is 1/4. So 2 pi over 1/4 is 8 pi. Right? Divide by a fraction is the same thing as invert and multiply, so that's 8 pi. The phase shift is 0 because there is no minus c. It's 0. There is no phase shift. The vertical shift, of course, is 2 down. I talked about that first. So it's just the cosine function. The first thing it does, this minus 2 is reflects it. So instead of starting up here and drawing like this, it starts down here and draws like this. And its period will be 8 pi. So again, I mark these tick marks as I'm going along, but I don't label them until I know where I want to draw one period. So I know I want to be between 0 and 8 pi. So 4 pi would be the middle of that would be 2 pi, the middle of that would be 6 pi. So those are my 5 points I want to plot that give me the shape of the cosine function. Reflected about that x-axis, which in this case is the line y equals minus 2 because I'm shifting down. Amplitude of 2, period of 8 pi, and no phase shift there. All right, now, in this example, we want to find the equation for the following graph. We have an amplitude of 3, and its period is pi, and we want the sine function with no phase shift. Okay, we want the sine function with no phase shift. Now, the thing is that it just gave you this picture. So you could think of this as the sine function, because sine of 0 is 0, has no phase shift, or you could think of it as the cosine function with a phase shift of pi over 4, however you want to think about it. Okay, because period's pi. So I can draw a sine function amplitude of 3. There's one period from 0 to pi. So the middle points are pi over 4 and 3 pi over 4. It just kind of squeezes it in instead of having a period of 2 pi. Amplitude's 3. So it squeezes in and pushes up. All right, and there is no vertical shifting here. Or again, I can think of it as a cosine shift with a phase shift of pi over 4. Okay, so how do I do that? Well, amplitude's 3, either one. The b is 2 to get my period to be correct, right? My period has to be pi, so 2 pi over 2 is pi. Now I need to figure out what this guy needs to be to get a phase shift of pi over 4, because that's what the phase shift of the cosine would look like if I shifted by pi over 4 units. So 2x minus pi over 8.